Well, hey there, guys and girls. Today's lesson is on creating pattern rules, and I just want to go over a couple of things, review a couple of things before we get started on creating these pattern rules. Okay, so first off, we will discuss what a variable is, and a variable is simply a letter or a symbol such as A, B, or N. Sometimes it's represented as T or X that represents a number. Okay, so in your algebraic expressions, which we're going to start to create, these are a combination of numbers and letters, and they may include operation signs like plus, minus, multiplication, and an example of that would be something like this. So just say 3n plus 3. Well, the n here is the variable because the n is going to stand for a particular number. And the reason why we create algebraic expressions is that if we had a particular pattern that we saw, right, a series of figure numbers, and we wanted to determine the 50th figure number, well, we could create a table of values and go up to the 50th number. We could do all these different things that would be very time consuming. But if you come up with an algebraic expression, such as the one that I have on the screen there, it makes it very easy to substitute. So if we have the variable n, at any time, we can take out n and we can put a number in there and solve a particular equation. And that's going to make more sense sort of as I progress with this video. But that's kind of what you just need to remember. Variable is a letter that stands for a number, and an algebraic expression would be something that looks similarly to that. Okay, so the model that you have in front of you would be something very similar to what we're going to do with the work after this lesson. So you have figure 1, figure 1, figure 2, and figure 3. And you'll always see this. So when we have a series of models, they'll either be called figure numbers or they will be called term numbers. Figure number, term number, same thing. So you have 3 figure numbers here, and we have to figure out, okay, well, how do we get the algebraic expression out of this? What we want to look at is a couple things. What changes? That really helps us to determine this. And also, what stays the same. So let's see here. Let's first do what stays the same. So in each figure number, it's the red tiles that stay the same. They're the constant. There's always 3 of them. And the way we represent that in an algebraic expression is in the form of addition. So whatever stays the same is plus, and because it's 3 red tiles in this case, in the algebraic expression, it's going to take the form as plus 3. Okay? Now we're going to look at what changes. And it is the purple tiles that change, right? In the first figure, there's 2. Second figure, there's 4. And in the third figure, there is 6. So what is it increasing by each time? Well, it's increasing by 2. And we're going to represent, when things change, it gets represented as the number that it increases by. In this case, it's 2. And then we're always going to have a variable beside that particular number. And the reason why we do that, because in this case, it's increasing by 2, but it's also 2 times the figure number is going to be the number of blocks in each figure number. So for example, 2 times 1, because this is figure number 1 in this particular case, 2 times 1 is 2. How many purple blocks are there? 2. If we go to the second figure number, again, increasing by 2, 2 times 2, the figure number there is 4. How many purple blocks are there? There's 4. Again, increasing by 2, 2 times 3, if we use the third figure number, 2 times 3 is 6. And how many purple blocks are there? There is 6. So again, whatever stays the same gets added to the equation, and whatever changes, you have to see what it's increasing by, what is the change, and that will take the place as 2 times the figure number. Now let's try it out. So we think we have the algebraic expression that's going to represent these figure numbers here, but let's test it. And the reason, or the way we test it is we start by writing the algebraic expression, and instead of the variable, we're gonna pick a figure number to substitute into that variable and then see if it equals the number of blocks. So, for example, let's pick a figure number. I like to always pick a figure number bigger than 1 because that will allow us to really see if we got the right algebraic expression. Sometimes if we use number 1 in our equation here, it doesn't always mean that we found the right expression. And when I do the review in class tomorrow, I'll show you that. So let's pick 3. Okay, figure number 3, instead of n, we're going to put 3 in there, plus 3 equals. So this algebraic expression should equal the number of tiles in figure number 3. So 2 times 3 is 6, plus 3 is 9. How many tiles are there in figure number 3? Well, there's 6 purple and 3 red, so that equals 9. So that algebraic expression is correct. We'll try another one. Instead of the n as a variable, we'll put in, let's do figure number 2. Put in 2 there, plus 3. What it should equal is 4 blocks there, plus a 3. It should equal 7. Let's see. 2 times 2 is 4, plus 3 is 7. So, bam, we found our algebraic expression. All right, this is another question that you might see, and this is the language that might be used as well. Determine an algebraic expression for the nth term of the following sequence. So what that means is we should be able to come up with an algebraic expression where we can figure out any figure number that we want. And that's what the nth term means. It means kind of like an unknown term, any term that we want. So right now, all you're shown is figure number 1, 2, and 3. Well, what if we wanted to determine figure number 56? Yeah, we could continue these blocks and draw it all out and everything. That would be very time consuming. Or if we find an algebraic expression, then all we have to do is take out the variable in the expression and substitute any particular figure number, and we will be able to determine the number of tiles in that figure number. And that's why we do this, okay? So right now, this question, again, you have different color tiles, so you can clearly see what stays the same and what changes. So, and these are the notes that I want you to make. Changes, stays the same. What you should be doing is writing when things change, what does that look like in an algebraic expression? And when things stay the same, what that looks like in an algebraic expression. So let's do what stays the same first. So what stays the same is these green tiles here. And there are 5 green tiles that never change, so they are going to look like plus 5 in our algebraic expression. What changes here? The orange tiles change, right? There's 3 in the first one, 6 in the second, and 9 in the third. So it's increasing by 3 each time. So it's changing by 3. What changes? Well, it's increasing by 3. And what does it look like in an algebraic expression? We always represent it as 3 times the variable. So our full algebraic expression should look like this. 3n plus 5 equals, and whatever it equals, that means number of tiles. So, oops, tiles. I'm gonna erase that. Number of, where's my green? Tiles. Okay, so these are the kinds of notes that you're going to want to take for this video. So if you have to go back and watch it again, please do that, because it's going to make your life so much easier in this particular chapter if you know, okay, what stays the same is what gets added to the equation. What changes is 3n or 4n or something times n. And then on the other side of the equation here, after the equal sign, always is the number of total tiles in the figure, okay? So the variable is always the term number. And on the other side of the equation, on the equal sign, is always a number of tiles, okay? So you really need to know that in order for all of this to make sense. So now let's try this out. Let's take out n and let's put in a figure number and see if it equals the number of tiles in that particular figure number. Again, I like to do figure number 3 or higher, just because it's easier to tell if you got the right answer there. So instead of 3n plus 5, we have 3. We're choosing figure number 3. So you're going to put that in for n plus 5 equals. Well, 3 times 3 is 9 plus 5 is 14. Go back and count the number of blocks in figure number 3. There are 9 orange and 5 green, which equals 14. Okay, so we know that we found our figure number. This is correct. Okay, so this is your question that I'm giving you for this video. I am expecting you, so this is a new year. I'm actually going to go back to you guys submitting your answers from the videos on Google Classroom, just so I can see who watched the video. I get proof of that, because you wouldn't be able to answer this question unless you watch the video, and B, it tells me whether you understood the video or not. So I kind of peruse the answers that you gave, that you give, and then I kind of see where I need to go from there in terms of my review the next day. So this is the question that I want you to answer. So yes, I want you to answer which part changes and what stays the same, but also I want you to create the algebraic expression. Okay, so for example, is it 4n plus 1 or 5n plus 3 or what have you? So I want you to create the algebraic expression and then also tell me which part changes and what stays the same. Because once you do that, you figure out the constant and the variable, then it's easier to create the algebraic expression. Again, if you didn't understand this, please go back and watch it again, make notes, watch it a third time if you need to. There's no harm in doing that until you understand it, okay? Alrighty, so I will leave you with that. Please put your answers on Google Classroom. I'm gonna submit this as an assignment, and I will see you guys tomorrow.